right, so this is going to be part 2, our notes from yesterday. So when we get through with this paper, we'll glue it in our journal also. So the first 4 are just your basic moves. First 2, we're putting them in scientific notation. So on number 17, and they give you more of a situation here, because usually when we're dealing with scientific notation, it has some science base to it, obviously, and it's either really big numbers or really small numbers. That was our point of using it, although you can use it with any numbers. So 17 said the temperature in the core of the sun is 27 million degrees Fahrenheit. All right, so where's the decimal right now? Yeah, it's behind that last 0. And where do we want the decimal to move? Yeah, we want it right behind the first number. So it's actually having to move 1, 2, 3, 4, 5, 6, 7 times. So that 7 is going to be our what? It's going to be our exponent. And we can drop off all zeros, so we just keep the 7. Okay. How many got number 17? Okay, good. All right, then number 18 says the length of an adult fruit fly is 0.004 of a meter. All right, so now the decimal's in the front, so what do you know about the exponent? It's going to be a negative exponent, because where do we need that decimal to move? Behind the 4. So we're moving it 1, 2, 3 places. So 4 times 10 to the negative 3, because it started in the front. It doesn't mean that's a negative number, just that it's a negative exponent because it's a decimal number. Okay? How many got that one? Okay, good deal. All right, then 19 and 20, they were really the easiest thing that you do with scientific notation is putting them back in standard form. We said the exponent tells us what? How many times to move the decimal. Not how many zeros, but how many times to move the decimal. Because these 2 7s are already taking up 2 of the places, so I need how many zeros? 6. So I would have 177 million. All right, then 20, it says the mass of a snowflake is 3 times 10 to the negative 6 kilograms. So what do we know about this number? It's going to be a decimal. Yeah, so our decimal needs to move to the left 6 times. So how many zeros am I going to have to put in front? 5. And you can put a 0 in front of the decimal. I'm not real picky about either way on that. You'll see it both ways. But behind the decimal is crucial. Okay. All right, is everybody good on 17 through 20? Changing, you're okay. All right, now let's look at the next little set, because I feel like this is where you struggle most on the homework. All right, so number 21, it says we're adding. So what do we know we have to make sure of first? That the exponents have to match, and they do. So we know our answer is going to have times 10 to the 7th. That's a given. And then 9.7 plus 4.3. Just remember to line up your decimals when you're adding. So I'm getting 14 times 10 to the 7th. Now, is that number in scientific notation? No, it's too large, because remember, to the left of the decimal can only be 1 digit, and 0 is not big enough. So I need this decimal to move here, and if I move it 1 place to the left, what happens to the exponent? It goes up. So I would have 1.4 times 10 to the 8th. Yes, Grace? because 14 times 10 to the 7 is not in scientific notation, because 14 is too big. Our rules for, and you had it yesterday, let's see. They didn't really spell it out for you on that sheet, but yesterday they talked about when you're writing in scientific notation, they gave you like 2 things. But what they really should have put on here, and what we can add to it, is when you're putting a number in scientific notation, it has to be a number larger than 0, less than 10. Think about 1.4. Is that larger than 0? Is that less than 10? Yes. 14, is that larger than 0? Yeah. Is it less than 10? No. And I say larger than 0, really I should say 1 or bigger is what I should say, because even like 0.9 is larger than 0. So really I should be saying 1 or bigger. So you have to have 1 digit to the left of the decimal. And right now I have 2. So it's too big. So I have to move my decimal and make it 1.4. Right here is where we're looking at. 1 digit to the left of the decimal. You'll see. We get it. You'll just be like, oh, okay. All right. I believe her. All right. Look at number 22. That's still adding. Do my exponents match? No. All right. So I've either got to go with -3 or -2. Let's go with the bigger one. Which number is bigger? The -2. So if I want this to become bigger, which way does the decimal move? To the left. So if I make this into 0.51 times 10 to the -2, okay. Brandon, was this, where's Brandon? Brandon, you were asking me at the beginning of the class about what to use. Was this where you're talking about on your multiplication signs?
I was just asking which one did you prefer.
Oh, okay. Now, with scientific notation, we definitely use the X for our times. I mean, that's just the way it's set up. But that's really about the only place we use an X anymore for multiplying, because we have so many variables that we'll be working with. But this, we're okay to use the X, because there aren't any variables with scientific notation. All right, so now we've got our exponents matching. We're adding, so 7.2. Remember, just line up your decimals. And my decimal's in the correct spot. It's just 7.7, so 1 digit to the left of the decimal, so I don't have to adjust. All right, go ahead and see what you can do with number 23. Do number 23. Okay, so you had some choices. You had to make the exponents match, so you could have either made the 4 into a 6, or you could have made the 6 into a 4, or you could have made them both into a 5. Or for that matter, you could have made them both into a 10. It doesn't matter what you make them, they just have to match, okay? But just save yourself some work. I'd probably only change one of them, okay? But you'll still get the same answer. All right, so did you go big or go small? All right, let's go big. So that means we're changing the 4 to the 6, so what do we have to do? Yeah, the decimal's going to have to move to the left 2 places. Oops. Not 3. Okay. And we're adding, so I don't really have to write that to the side. I'm just going to have 8.073 times 10 to the 6. How many got that one? Okay, good, good. All right, now let's look at 24. We're multiplying. Do the exponents have to match? No, but what do we do now with the exponents that we're multiplying? Add them. So we know we're going to have something times 10 to to the 7th. But we can get that out of my way. And then we just have to multiply 2.4 times 5.3. We're going to just old school it here. So what do we got? 12, 7, 20, 12, 2, 7. So I've got 1272. You can't really read it. I'm going to put it over here. And right now it's this. 12.72. Sorry, that's kind of squished up. Times 10 to the 7th. Am I good with that? No. Where's the decimal got to go? Behind the 1. So if I move it behind the 1, what happens to the exponent? It goes up. So I'd have 1.272 times 10 to the 8th. Yes, Will.
I had no idea if we were, I tried to make the exponents, and I got the same answer.
Yeah, you'll just, well,
I get different exponents.
yeah, but your exponent was different, right? So, see, it's not the same answer because your exponent, it's really like place value. Because if you expanded your number out and I expanded my number out, we don't have the same numbers anymore. So, everything has to be an exact. Yeah. Okay. All right, go ahead and try number 25. Do 25. All right, we got it. Okay, so we're multiplying. So what do we do with the exponents? We add them. So you got -3 and -8. So what is -3 plus -8? -11. I hear you mumbling. Okay. And then when you multiplied 7.5 times 5.6, what did you get? 42. Are we good with that as our final? No. Where's the decimal got to go? Behind the 4. And then what's going to be our new exponent? -10. Because if we're adding to -11, we're at -10. How many got that one? Okay. Getting better. Better. All right. Then number 26, we got 6 times 10 to the -2 divided by 8 times 10 to the 7th. All right. Now, when I'm doing dividing, I like to see them stacked. You don't have to. But if I see them stacked and it's a 6 and an 8, what's 6 and 8 reduced to? 3/4. Well, I didn't really mean to make that line so long. Kind of ignore that line is so long. And then what do I do with exponents? Subtract. When they're stacked, we subtract. So -2 minus 7 is what? -9. Now, what's 3/4 as a decimal? 0.75. That was easier to me. That was easier than dividing 6 by 8. You do it either way you want. But 3/4 we know. All right, is 0.75 times 10 to the -9 okay? No. Where's the decimal need to go? Behind the 7. And if I move the decimal to the right, what happens? The exponent is going to decrease. So if I'm decreasing a -9, what's it become? Yeah, and I'm kind of running out of room, so I'm going to write it on its number. Yes. -2 minus 7 will give you -9. Yeah. And you don't have to reduce that to 3/4. I mean, we could have done 6 divided by 8. You still get 0.75. That's the way mine works, is I see the 3/4 and I know 0.75. Okay. All right, now 27 and 28, they did write it as a fraction, which I think is easier. Go ahead and do number 27. All right, so what did you get when you divided 1.7 divided by 2? Leah? Yeah, 0.85, because think about it, half of $1.70, it's 85 cents. Think about it that way. So 0.85 times 10, and then what do I do with those exponents? Subtract. When they're stacked, we subtract. So 4 minus a negative 2 is what? 6. Am I good here? No. Where's the decimal need to go? Behind the 8. And moving the decimal to the right does what to my exponent? Yeah, it decreases. So I'd have 8.5 times 10 to the 5th. How many got that one? Okay, good. All right, now let's look at 28. 28, they kind of gave you a combination. You've got to do the top first and then do your dividing. Because when we've got problems set up with fraction bars isn't just another way of grouping. So everything that's on top is in a group. So you've got to simplify that first, and then you work through with the dividing. All right, so let's just kind of work through it together. We're multiplying, so do exponents have to match? No. So what is 4 times 6? So I have 24 times 10. What do I do with these exponents? Add them. So 3 plus 8 is 11. And I just leave it at 24 right now. Don't stress about that. It's not in scientific notation because we're still working with it. And then on the bottom, I have that 5 times 10 to the 14th. All right, so 5 into 24, I'll just work it over here. How many times is 5 going to go into 24? Yeah, 4. And then 5 into 48. So we're looking at 4.8 times 10. And then what do we do about these? Subtract. And 11 minus 14 is negative 3. So 4.8 times 10 to the negative 3. So that's why we didn't really worry about this 24 times 10 to the 11th wasn't in scientific. It'll work itself out. Okay, you don't worry about that to the very end. Okay. All right, we're almost there. Let's look at 29. It says find the difference of 3.2 times 10 to the second minus, and I'm thinking how I'm going to write it, and 8 times 10 to the fourth. So difference means subtract. Now, my exponents don't match, so do we want to go big or go small? Let's go big. So this 3.2 times 10 to the second really needs to be 10 to the fourth. So where's the decimal going? To the left, how many times? So I really have 0.032 times 10 to the fourth minus 8 times 10 to the fourth. Okay? And technically, if I was going to put this in on the calculator, we're not, but if I was, when it's written like this, those parentheses matter. Because if not, your calculator kind of takes it as you enter it, and it can get you messed up depending on how you enter it. So just know, be careful with that. All right, we don't need our calculator. 0.032 minus 8. So that's the same thing as writing negative 8 plus 0.032. You're just subtracting. We just know our answer is going to be negative. All right, so subtract that out, see what you get. I'll let you do a little work. All right, so did you get, and that's going to end up being a negative. So negative 7.968 times 10 to the what? Fourth. Because we're subtracting, so we just keep our exponents. So negative 7.968 times 10 to the fourth. Okay? Because remember that minus, that meant our 8 was negative. Was that your question? Okay, yeah. Okay. All right, and then the last one, it says the population of Alaska is approximately 6.5 times 10 to the fifth people. The population of Illinois is about 1.3 times 10 to the seventh people. How many times greater is the population of Illinois than the population of Alaska? Anytime you see the how many times greater, that means to divide. Okay? You kind of think, because it's saying, oh, the word times, but you're looking for how many times does it take to make that up, so you're dividing to find that answer. Okay? So it says, how many times greater is the population of Illinois than the population of Alaska? So that tells me that Illinois is on top. And Alaska's on the bottom. All right, you go from there. All right, so hopefully you remembered your rules. When you set that up to divide, 1.3 divided by 6.5, you can't divide by a decimal number. You have to make that a whole. So it's really dividing 65 into 13, which is 65 into 13.0. So how many times is 65 going to 130? 2, so it'd be 0.2 times 10. And then what do we do about these exponents? Subtract. So we got 2. Can I leave it here? No. So the decimal's got to go where? Yeah, to the right. So I had 2 times 10 to the what? First. And I probably would go ahead and put the 1, even though the 1's understood, just because we're writing it in scientific notation. We kind of need to see that exponent just to know we're done with it. Okay? All right. We're going to put this in our journal. It goes right along with the scientific notation. Hopefully that helped.